So dear friends, this is the figure representing the question. I wanted to tell you something. This figure was not given in the question. This is a figure that I have drawn. So let us see whether this figure complies all the conditions stated in the question. So this is position, this is the position A, and this happens to be position B, and they have said that position B is 4 meters at higher level. So the level difference will be 4 meters. It's shown over here, and the diameter at position A is 200 mm and it is changing to 500 mm at position B. So it's a tapered pipe and it's also an inclined pipe. We get the idea about the tapering from this statement. The diameter 200 mm at a position A to 500 mm at position B. So here the diameter is 200 mm and here this diameter is 400 mm, and position B is 4 meters at higher level. So I have drawn the datum through point A because by doing so I can take ZA equal to 0. I hope you all remember that concept. If the datum, if you don't have a direct reference to the location of datum, location of datum, it's better you take datum through one of the locations, one of the points, and thereby making Z representing that point 0. If you draw datum through here, you can take ZA equal to 0. If you draw datum here, you will have ZA and ZB. And since we have no direct reference towards the values of ZA and ZB, you will get stuck. You will get stuck while finding out the ZA and ZB. So it's better you draw datum through this point and thereby making ZA equal to 0. Now we need to find out loss of head and direction of flow. So let us find out EA. Energy at A, EA equal to PA by rho G, VA square by 2G, ZA. ZA will be equal to 0. Now let us find out VA square by 2G. Discharge is given as 200 liters per second. That means that is 0.2 meter cube per second. So let us find out VA. VA is equal to Q by area at A. That is Q is equal to 0.2 divided by pi d square by 4, which is equal to this is VA. I've written it wrongly. VA, that is VA equal to 6.369 meters per second, VA. Now what is the value of PA? PA is 9.81 Newton per centimeter square. PA equal to 9.81 Newton per centimeter square. That is 9.81 into 10 to the power 4 Newton per meter square. Therefore EA will be equal to 9.81 to 10 to the power 4 by rho. That is specific gravity is 0.87. So we need to convert it into density. 0.87 times 1000. That is rho into 9.81 plus 6.369 square by 2 into 9.81 plus 0. That is equal to let me take my calculator. Total energy, it will be equal to equal to 13.56 meters. Let us write EA equal to 13.56 meters. Let us now find EB. energy at B equal to PB by rho G plus VB square by 2G plus ZB. ZB equal to 4 meters. VB. Let us find out VB. VB equal to Q by area at B. Q is equal to 0.2. Area at B is equal to pi into 0.5 pi d square by 4. VB will be 1.018 meters per second. And PB will be 5.886 into 10 to the power 4 Newton per meter square. Therefore, EB will be 5.886 into 10 to the power 4 by rho happens to be 0.87 times 1000 rho into G plus 1.018 2 times 9.81 plus 4. Let me take my calculator and do. It's equal to 10.95 meters. EB equal to 10.95 meters. meters. So from here we can say that EA is greater than EB. Therefore, the flow happens from A to B. The flow happens from A to B. The flow happens from A to B. Since energy at A is greater than energy at B, the flow happens from A to B. Now, there is one very interesting thing. You may have a feeling that flow may happen from B to A because this is inclined in such a way that it's inclined like this. So we may get a feeling that the flow happens from B to A, but that's not the case. We cannot say like that without looking at the energies. Since energy at A is greater than B, the flow happens in upward direction. So we may think that it's not physically possible. We may have that intuition that the flow may happen from B to A, but we cannot say that with surety without looking at the energy values. So since energy at A is greater than energy at B, the flow happens from A to B. Now the head loss is equal to EA minus EB, that is 2.61 meters. So this is how you have to do. So I wish to remind something. If the question is to determine loss of head, you have to consider the flow, in fact the fluid as a real fluid, and you have to take the equation for real fluid. And if the direction of flow is asked, you have to check for the energies at two different points and you have to compare.